Hello everyone, welcome to the course on engineering graphics. Section of solids and development of lateral surface. We are going to discuss about this module in two sessions. This is the lecture 1 on section of solids. In lecture 2, we will see the development of lateral surfaces. We are going to cover these topics today, that is cutting plane parallel to HP and perpendicular to VP, and cutting plane inclined to HP and perpendicular to VP. Horizontal cutting plane or cutting plane which is parallel to HP and perpendicular to VP. So the cutting plane which we would be using for cutting the solid, that plane is parallel to HP and perpendicular to VP. So we will see such cases wherein the cutting plane is parallel to HP, perpendicular to VP, and we will see the solution of such cases wherein it is cut by horizontal plane. This is also called as horizontal cutting plane or a cutting plane which is parallel to HP and perpendicular to VP. Let us see case-to-case examples. So question 1, square pyramid. The solid is a pyramid with edge of base 60 mm and axis height 90 mm is standing on its base on HP. So the solid is a square pyramid. It is standing on its base on HP with two of its base edges parallel to VP. It is standing on HP in such a way that two of the base edges are parallel to VP. It is being cut by horizontal cutting plane passing from a point on the axis 20 mm below the apex. Draw the elevation and sectional top view. So this solid which is resting on HP on its base is being cut by a horizontal cutting plane which is parallel to HP and perpendicular to VP. The cutting plane is a horizontal cutting plane and the cutting plane is passing from a point on the axis 20 mm below the apex. Okay, so we are supposed to draw the elevation, that is the front view, and the sectional top view. So just imagine the solid. So you have a pyramid. This is a square pyramid. The square pyramid is standing on HP on its base with two of the edges, with this edge and another one are parallel to VP. VP is here on this side and we are observing it from this side for front view. So it is standing on HP on its base. It is cut by a horizontal cutting plane. So the cutting plane is parallel to HP. This is the cutting plane. This is parallel to HP, so it is called as a horizontal cutting plane. It is passing from a point on the axis 20 mm from the apex. So if you continue with this solid, now I have shown you the cut portion. Before that, before cutting, it was a continuous pyramid having apex, and this is cutting 20 mm below the apex. So 20 mm from the apex, this is passing and removing the top portion. So major portion is retained. So that is, this is retained. And we have got this section. What we are supposed to draw? We are supposed to draw the front view. That is whatever is remaining here. And the sectional top view. Looking from the top after taking the section, whatever is visible, that is what is required to be drawn. And that will come in the sectional top view. Okay, let us see the solution of this in AutoCAD. So this is the front view and the top view of the pyramid without cutting. So it is a pyramid, a square pyramid standing on its base on HP. So it has its base on HP in such a way that two of the base edges are parallel to VP. So this BC and AD, these two base edges are parallel to VP. So VP is here and it is standing. So the dimensions are 60 mm base edge and 90 mm axis. So it is shown here. This is the front view and this is the top view. Now we will show the cutting plane position and incorporate the section in the top view. For that cutting plane, the line convention is cutting plane line is same as center line with the dark ends, okay, and the arrowheads. So 20 mm from the apex. So from this we are going to measure 20 mm. So this is the cutting plane. It is passing from a point 20 mm from the apex. So if you see the dimensions, 20 mm from the apex, the horizontal cutting plane is passing. Horizontal is parallel to HP. So this is seen as a line in the front view, a line which is parallel to XY line. So this is the cutting plane, and the convention is cutting plane line is like a center line except the dark ends. So dark ends we have to show. The direction of observation, and now we will name the points where it is cutting the slant edges of the pyramid. So this is one point and this is another point where it is cutting. Actually the two slant edges are here, AO and BO, and here CO and DO, these two slant edges here. So these are actually 2 points overlapping. These are also 2 points overlapping. So let us give the names to these points. Height is 4, text orientation is okay. P prime 1 and so we have got the 4 points here, Now let us transfer these points on the top view. Just see before that what is happening. Because of the cutting plane, we are removing the top portion, and whatever is retained is the maximum. Bottom portion is retained. Below the cutting plane, whatever is there, that is retained. So this portion is gone, it is being cut, so that we can delete or trim. Alright, even if you show the axis, that is not a problem, but you can keep the axis if you want. And that slant edges, those slant edges will show with projection line only, because those are removed now because of the cutting plane. So this is actually the complete sectional front view. Because of the cutting plane, this is what is the front view. Now we have to transfer the points in the top view and generate the top view. Let us transfer the points P1, P1 is on OA, so P1 is on OA, this is P1, okay. Similarly, P2 is on OB, this is the P2, P2 is on OB, so P2, P1, and P3 and P4, so this is the P3 and this is the P4. Now let us join them. I will switch on ortho and switch on the snap mode, so it is easier to select the points. I have not transferred P3 correctly. I have to do it properly again. So I have taken correct projection now from the point from P3, P4 and got the points here in the top view, and then later on connected those points. Internal things have been removed, so removed all the internal slant edges, and O is also gone. O can also be deleted. O is not there now, remaining apex is gone, is being cut. And this portion is shown hatch because that is what is being cut, okay, because of the cutting plane. Because of this cutting plane, this is what is the section. So what do you think, that this is the true shape of the section? Yes, it should be true shape because the cutting plane is parallel to HP, and because of that this is the top view of the section. And since cutting plane is parallel to HP, this top view will be showing the true shape of the section. Okay, because the cutting plane is parallel to HP, This is the true shape of the section. The section shape and size is true. Okay, so this is the solution now. So this is the solution we have got. Let us take this example now. A square pyramid with edge of base 60 mm and axis height 90 mm is standing on its base on HP with all its base edges equally inclined to VP. It is being cut by a horizontal cutting plane passing from a point on the axis 20 mm below the apex. Draw the elevation and sectional top view. Now this looks almost similar to the previous sum. It is a square pyramid, edge of base 60, axis height 90, is standing on its base on HP. This much is similar. Now here the difference is there. With all its base edges equally inclined to VP. Now all the base edges are equally inclined to VP. So they will make 45-degree angle with XY line. It is being cut, then the cutting plane is again horizontal and it will pass through 20 mm below the axis, below the apex on the axis. It is similar. Now let us see the section here for this case. Just imagine the solid. It is like this. Okay, here all the base edges are equally inclined, so it is like this. You are seeing from here. So this is a slant edge, this is a slant edge, this is a slant edge. These three slant edges will be visible in the front view, and the cutting plane is passing from a point on the axis 20 mm below the apex. The top portion is removed, so this is what is done. And this is what is the section, true shape of the section, because cutting plane is horizontal. Now let us solve this on AutoCAD. This is the front view and top view of the solid. Now here the cutting plane is passing 20 mm from the apex. So that will show, understand the positioning. All the base edges are equally inclined to VP. So all the base edges making 45-degree angle with XY line. And that is how we have drawn this, the front view and the top view. Now we'll locate the cutting plane here on this. Cutting plane line is like a center line with the dark cutting with the dark ends. So that is what we are drawing now. And the arrows pointing the direction of observation. This is the cutting plane line. We will give the names to these points. Okay. Because of this cutting plane, this top portion is being removed, section is taken. We can show that with the construction line. We can show that with the construction line. Okay, now let us transfer the points on the top view. We've given the names to those points. P3 is on OC, single point. P1 is on OA, so this is the point P1 and this is the point P3. Now let us see how to transfer the point P2 and P4. You cannot directly transfer them here because the slant edge seems to be vertical there. How will you transfer here? You cannot transfer it directly with this, like this P3 and P1. Then we have to adopt some method. For that, what we'll do, we'll first transfer it on the end generator or end slant edge on the corner, from the corner. So on this end, this is the slant edge, or on this side OA is the slant edge. So either you transfer it on OA or OC horizontally. Here, because of the cutting plane, we have already got the point here because of the cutting plane line itself. So this is that point. So we have got the projection. Okay, I will take it properly. Ortho mode. This has not been selected while drawing the line. Ortho. Vertical line. Okay, so now we have got this point here, same level. We have got this P2 and P4. Now from this we will take an arc of a circle. Start, center, end, and complete this part. This is the starting point for the arc. This is the center and this is the end. So we have got this by the arc of a circle, keeping this at the center and this much as the radius. We have drawn the arc, and the intersection of the arc, the intersection of this arc with this OB here, this is that point. This is the point P2, and intersection with OD, this is the point P4. Just see here, since we cannot transfer it vertically directly, we have to transfer it first horizontally on this end slant edge. Either this one or this one, anyone will do. So we have transferred it, suppose here. Now this is the projector for that, or by chance here we have got it overlapping, so whatever it is the case, so this is that projector for this, and this projector, by this projector we have taken it on the top view of the slant edge here OC, and from this with the center we have rotated this and got it on this OB and on OD here. So this is our point P2 and this is a point P4, this is a P1, this is a P3. So once we have got all the 4 points, let us connect them. So this is the connections done, and the central portion has been trimmed out. This O will also go, and we have got this hatching here inside because this is the cut section because of the cutting plane, and it is a true shape of the section because the cutting plane is a horizontal cutting plane, and this is the top view. So top view is showing the true shape of the section because of the horizontal cutting plane. So this is the solution here. Now let us take this example. A right circular cone of diameter 60 mm and axis height 70 mm is resting on its base on HP. Now the solid is a right circular cone and the diameter of the base 60 mm, axis height 70 mm is given. It is resting on its base on HP, this is also given. It is being cut by a horizontal cutting plane which bisects the axis. Draw the projections. So now this is being cut by a horizontal cutting plane, and the horizontal cutting plane is bisecting the axis. So we have to show the front view and the top view for this case. So just imagine the solid, it is a cone, it is kept on its base on HP, and the horizontal cutting plane is passing and bisecting the axis. So top portion is sliced out, top portion is removed from this, and this is what is the section and the portion retained. Let us solve this on AutoCAD. So this is the front view and the top view of the cone without the cutting plane. Simply it is kept on its base on HP. So these are the two views. Now we'll position the cutting plane and show that section in the top view. Cutting plane is horizontal cutting plane and it is bisecting the axis. So in this case, axis, this is I already bisected the axis and shown this as a point. Now cutting plane will pass through this point. So cutting plane line we have to show from this point. Okay, so this is, now we will show this as a cutting plane line. So end point should be dark. So this is the cutting plane line. Now because of this we have got a few points on the generators, and on the slant this extreme generators also the points are there. So we will name those points and then transfer those points in the top view and then connect those points. Okay, let us see this thing being done. Basically these points are easier except this point, this we have to transfer like the process we have used for pyramid. So let us see this first. So we have to transfer the point P3. This is this actually 2 points would be there, one on OC and another will be on OG. So P3 and P7 points are there. So how to transfer those points? So the process is same. We have to first transfer them horizontally. We have to transfer them horizontally. Okay, so this is done here horizontally on the end generator, and from this point we should transfer them down. Let me notate, give the notation to this point. This is also point here. Okay, now we have to transfer this on the end generator. This is already done due to cutting plane itself. So whatever is the case, this is that point on the end generator. Now we'll transfer it down. We will transfer it down. So we have got this projector from the end generator to this here. This is that point. Okay, so this is somewhere here. Now we will take this arc and transfer this on the OC and OG. For that arc, start center end. This should be the start point for the arc. Ortho should be off. This is the center and this is, let us say, the end. So this is going to give us 2 points. One is on OC. This is the point P3. PO is for point. This is the point P3. And this is the point on OG, which is the P7. Okay, so rest of the points directly we can transfer now. For example, this point will directly transfer it. This is on OD and OF, so we will get a vertical projector. Okay, OD. So this is the point, and OF is this point. Like this we will get the rest of the points and join them with a freehand smooth curve. So we have transferred all the points, and then once we have got the points, we have connected them with a smooth curve. Now since the cutting plane is horizontal cutting plane, the true shape of the section will be visible in the top view, which is again a circle. That is true because cutting plane is horizontal, and it will cut it such a way that the circle will only be visible, because this is a cone resting on its base on HP. So this is the true shape, which is again a circle. So this is the solution now. Now let us see second type of cutting plane. Now this cutting plane is inclined to HP and perpendicular to VP. It is not now parallel to HP. Now it is making some angle with HP. So you can note that this cutting plane is now inclined. The angle of this cutting plane with HP is some angle. It is something, it is not zero now. It is making some angle with HP. So it is called as a auxiliary inclined plane. This is also called as the auxiliary inclined plane because it is perpendicular. This with respect to VP, it is still 90 degrees. So the plane is perpendicular to VP but inclined to HP. So this is called as a auxiliary inclined plane. The cutting plane is auxiliary inclined plane. Now let us see the examples for this. A square pyramid, base 40 mm side and axis 65 mm long, has its base on HP and all the base edges are equally inclined to VP. See, it is resting first. The solid is a square pyramid. It is resting on HP on its base with all of the base edges equally inclined to VP, means making 45 degrees with XY now in the top view. It is cut by a section plane perpendicular to VP. The cutting plane is also called as a section plane. In some of the cases it is also called as the section plane. It is perpendicular to VP and inclined at 45 degrees to HP. The inclination of the cutting plane with HP is 45 degrees, whereas the inclination with the VP is 90 degrees for the cutting plane. Draw its a sectional top view and the true shape of the section. Now herein, let us see the true shape. We have to draw the true shape as well, because the top view will get something in the top view. That shape will not be a true shape of the section since cutting plane is inclined to HP. Let us see this now. Let's try to imagine this solid. It's a pyramid. Okay, it's a square pyramid having all its base edges equally inclined to VP. So this is being observed here from this direction for getting the front view, and these base edges are making 45 degree angle with VP, and it is being cut by cutting plane. Now cutting plane is passing through the axis. It is cutting the angle of the cutting plane is 45 degrees. So cutting plane is like this and making 45 degree angle like this. This angle would be 45 with the HP for the cutting plane, and removing the top portion. So this is removed. So this is what is the section. This is what will be seen in the top view for the cut part. Okay, and let us see the procedure to draw the top view for this case. Now let us solve it on AutoCAD. So these are the two views before cutting it. The square pyramid resting on its base on HP with all the sides, with all the edges of the base equally inclined to VP, and this is there resting on HP. Now it is being cut by a cutting plane. The cutting plane is making 45 degree angle with respect to VP. The cutting plane is perpendicular to VP and inclined at 45 degree angle and bisecting the axis. The cutting plane is bisecting the axis. So let us show that. Bisecting the axis. So we have to draw a line at 45 degrees here. I will show this as a projection line first, and then we have to show the position of the cutting plane. This is going to pass through this point and making 45 degree angle. So passing from this point, and ortho should be off now for that, and making 45 degree angle. Okay, so this is the cutting plane. Now we have to transfer the points from this cutting plane. The top portion is removed because of the cutting plane. So this naming is important. So we are given the names to those points P1, P2, P3 and P4. Now we have to transfer these points onto the top view. So P3, P3 is on OC. So this is P3, sorry. OC, this is P3. Then how to transfer point P2 and P4? Again, now the procedure is same. Now here the cutting plane is inclined, so we directly don't have any horizontal line, so we have to draw the horizontal line here. Okay, and by horizontal line we have taken transfer this point on this end generator or the slant edge, extreme slant edge, and from this we will transfer it down. Okay, so we have got this point of intersection here. Now we will transfer this by an arc of a circle. We will transfer this by arc of the circle. Okay, so we have got the 2 points. This is the point P2 and this is the point P4, like this. Okay, and for P1 we will get it, transfer it vertically. So P1 is on OA. So we have got all the 4 points now. Let us connect these points. So we have got the names of the points here as well. This is a P1, then a P2, then P3 and P4. Now we have connected these points here in the top view, and the central part is removed, that is the top portion is removed. So we have trimmed that part in the front view as well as from the top view and shown the hatching lines in the top view. So this is actually the cut section. But now since this cutting plane is inclined, this is not the true shape of the section. Understand, we have to draw the true shape of the section. Also, this is just the top view, and in the top view, since inclined cutting plane is there, this is of the apparent length. So we have to draw the true shape. In that case, we will draw this line again horizontally near adjacent. You can draw adjacent to the front view either on the left side or on the right side of the front view. Any side will do. There is no sign convention. There is no standard convention. Depending upon the availability of your space, you can draw it on any side of the front view. So I have drawn it here on the left side. This is just reproduce. Same line here is been reproduced here horizontally. Now we'll take the projections down from these points. So I will take the projections from these points for getting the true shape. So P1 with P1, so we have got the point P1 here. P2 with P2, so this is the P2. P3 is along the same, on the same line as P1. So it is on the same line. I do not draw this over this. P3 is the same, on the same line, and P4 so this is the P4. Now we have got the points. Let us connect this and show the section lines. So that will be the true shape. So this is how we have drawn this true shape here. Now since this cutting plane line had been made horizontal, this is the reproduction of the top view with these distances, and this is going to give you the true shape of the section. Whereas this is the top view of the section and this is the true shape of the section. The true shape and these two views. We'll see one more, or rather two more sums we'll see for section of solids. Let us see this one: a square pyramid, 60 mm base side and axis, 90 mm long, is resting on HP on its base. Okay, the solid is resting on HP on its base. The pyramid is cut by a section plane in such a way that the true shape of the section is a trapezium with parallel sides 40 mm and 20 mm. Draw the front view and top view showing the section. Also show the true shape of this section. Now listen here, the thing is that they have not given directly the inclination of the cutting plane as well as the positioning of the base edges with respect to VP. That is not directly given, but what they had said that it is being cut by a cutting plane in such a way that the true shape of the section is a trapezium. Okay, so we have to imagine that how it will be resting on its base on HP. So two sides should be parallel to VP, and then auxiliary inclined plane will cut it so that the section will be a trapezium, and then we will draw it accordingly and get the inclination. So let us see that here. Just imagine that the solid is positioned in such a way that two of the base edges, they are parallel to VP now, and it is being cut by an inclined cutting plane such that this is a trapezium. Okay, the top view section is trapezium, and this is 20 mm and this is 40 mm. So we have to draw this first and then get the inclination. Let us see the solution of this. This is actually the front view and the top view without the cutting plane. Now since the direction, actually direction we can take anyway, I mean direction of inclination, but the angle of inclination is not given, as well as the base edge positioning is not given, but they said that the section will be a trapezium. So in that case we will position it in such this way so that the cutting plane will cut either this way or this way. Anyway is correct. These 2 points will get here and 2 points will get here, and this should be 20 and this should be 40. So to get the position of the cutting plane, let us draw the true shape first. Okay, so for that true shape also we don't know this length, angle is not known. Then what to do in that case? We have to imagine that now it will cut here, but this dimension will remain same in the true shape. Okay, that this 20 and the major side of the trapezium is 40 mm. These two dimensions will be same in the top view apparent shape as well as the true shape. So we'll make use of this thing. So let us draw that here. So let us say, suppose, okay, suppose we keep it here on this XY line for the true shape. Now we have to adjust 20 here and 40 here. For that, the better is that it is center line will draw and it is equally distributed about the center line. So I have to draw say I draw here 10 mm and at some distance I draw a line of 20 mm vertical again. Okay, now I will reflect this about this line and I will get again 10 mm below and this 20 mm below. So I will have a line of 20 mm and 40 mm. Okay, so I will do that. So I have got this now equally distributed line segments. This is 20 and this is 40. Now we take the projections from these segments. So now I have got that here. Okay, and now I take a 40 mm segment. So I have got the points. These 2 points I got because of this 20 mm segment, and these 2 points I got because of the 40 mm segment. Now I will transfer these points by projectors on the front view. I've got the front view projector's intersection, these 2 points here, and I'll project this on the other 2 slant edges in the front view. So I got 2 points here and 2 points here in the front view. Now I join them with a line which will be the cutting edge, cutting plane line, and I will get the inclination of this, and once I get these two between these distances between these 2 points, I will project this here and get those projectors here and complete the true shape as well. So let us do that. So we have got the inclination of the cutting plane here by joining the points. We have named the points as well, okay, correspondingly from the top view. Connected the points in the top view. So this is the top view of the section. We can show hatching here, and now we will keep this horizontal here and get the true shape of the section. So this is how we have got the true shape of the section here by keeping this horizontal and taking the projections here again. So this is the complete solution for this sum. The complete solution is done here. Now let us see this one. Right circular cone of diameter 60 mm and axis height 70 mm is resting on its base on HP. It is being cut by an inclined cutting plane making 45-degree angle with the HP. Now the solid is a cone resting on its base on HP, and the cutting plane is inclined cutting plane making 45-degree angle with the HP and perpendicular to the VP. So this is auxiliary inclined plane. This plane passes through the point 15 mm above the base on the axis. Now from which point it is passing, it is given. It is 15 mm above the base on the axis, and we are supposed to draw the projections for this. Just imagine the solid. See, we had a cone and then the cutting plane has cut this. Okay, so this is what is the cut section of the cone. This is what is remaining. Now let us solve this on AutoCAD. So these are the two views of the cone, and the cutting plane has been also shown here. It is passing through a point on the axis 15 mm from the base. So this is that point on the axis which is 15 mm from the base. And the cutting plane is the inclined cutting plane making an angle of 45 degrees with HP. So the angle is 45 here for the cutting plane. Now this has been passing, and now we have named the points of intersection of the cutting plane. So these 2 points P1 and P2 on the base itself. Let us see the transferring of these 2 points. So projection line. Ortho mode on. So P1 and P2 we have transferred. Similarly, we can transfer other points, and P3 and P7. For that we have to transfer them horizontally. So P3 and P7 horizontally, and from this end generator we'll project it down, and then okay, it's not taken. I will again give it. Okay, so it is been transferred now to this end generator first. This is that point on the end generator. Now I will take and arc of a circle. So this is the start point, this is the center point, and this is my arc. Okay, I have got the points for P7 here on OG and P3 here on OC. So this is the way we have transferred these points P3, P7, and now P4, P6 simply vertically we can transfer. P4 and P6 and P5 is also transferred. Now we have got the points, we have transferred the points. Let us connect this point. Don't get confused, this is just for sake of transferring, this is not actual point. Points are here on the base P1, P2, and then we will give the names to these points in the top view and connect them. So we have given the name to the points and connected them with a curve, because this surface is circular or this cylindrical or rather conical surface. Okay, it is a curved surface, so we have to connect the points with a curve and not by straight lines, because it's a surface which is curved. That's the reason why we have to connect these points by a freehand curve, and then these two are the base points, P1 and P2. Okay, so that is actually the base. It is a part of the base. Because of this cutting plane, we have separated this remaining base, and this is the top view. And if true shape is asked, then we can make this horizontal and take the projections horizontally here, and we'll get the true shape if required. In this case they are not asked, so this is the solution for this sum. So this is the solution. Let us see one more sum. A right circular cone of diameter 40 mm and axis height 50 mm has its base in the HP. It is cut by auxiliary inclined plane which makes an angle of 45 degree to HP and passes through the point on the axis 20 mm below the apex. Draw the sectional top view, sectional side view, front view and true shape of a section. Okay, so what is given is a right circular cone, diameter 40 mm, axis height 50 mm. It has its base in the HP. It is cut by AIP, 45 degree angle with HP, and passes through the point on the axis 20 mm below the apex. So it is a 45 degree angle of the cutting plane passing through a point on the axis 20 mm below the apex. We have to draw the top view, the front view, the sectional side view and the true shape. So all the things are required. Just imagine the shape of the solid. So the solid is like this. Okay, it is a cone and 45 degree angle of the cutting plane. So cutting plane is making 45 degree angle and it is cutting, passing through a point which is 20 mm below the apex. This distance will be 20 mm, and then it is passing through that point and removing the top portion of the cone. Now what we'll see in the top and side view, this right side view is required because sectional side view is asked and the true shape is also asked. So just solve this. So the three views of the cone, the front view, the top view and the side view, right hand side view before cutting. Now we have shown the cutting plane here, 20 mm from the apex. This is the point through which the cutting plane is passing, making 45-degree angle. Okay, and then we have got the points. We have also named those points. So naming is also done. And we will transfer this onto the top view first and then onto the side view as well, and then connect them. So the points have been transferred on the top view as well as the side view, and then we have got the points here on the side view as well as on the top view. Let us connect them using a freehand curved portion. So curve, the point should be connected with a curve. This is how we have connected the points and shown the hatching lines here in this section as well as this section. And to draw the true shape, we had made this line horizontal here separately, taken the projections and taken the projections from the top view points, and by the points of intersection we have got the points here. We have joined them here. So this is the true shape of the section, this is the top view of the section, this is the side view of the section. So this is how the complete solution of the sum. So we will stop here today. In the next session on this content, we will discuss about development, and then this how to transfer the points on the developed part also we will learn. We'll take the same problems, but now we'll add the development of the lateral section, the development of the lateral surface of these solids in the next lecture. Thank you.